Hi friends, in this video we are going to see Laplace transform of standard signals. Before you continue watching this video, please go through. There is two videos I already uploaded related to this video. One is why we need to go for transform. Another one is Laplace transform definitions and ROC. So please watch those videos. After that, come to watch this video, then only you can easily understand the content of the video. Okay, so let's start. We will start from one of the basic standard signal, that is impulse signal or impulse function. If you take the Laplace transform of impulse signal, this is the definition of Laplace transform. Laplace transform of x of t is equal to minus infinity to infinity x of t e power minus st dt. Okay, so instead of x of t you are going to substitute the signal del of t, and we know very well that del of t, it is 1, it is unit impulse function 1 for only t is equal to 0, otherwise 0. This is your del of t, the graphical representation. This is t is equal to 0 and this is 1 and this is del of t, otherwise it is 0. So if you substitute instead of t 0, because it is exists only for t is equal to 0, and del of t is 1, del of t is 1 for t is equal to 0. So naturally e power 0, that is equal to 1. So this is the Laplace transform of del of t, and this e power 0 or e power minus s0, here this Laplace transform does not depends on s, because if you substitute t is equal to 0, naturally e power 0. So this function does not depends on s term. So naturally the Laplace transform of del of t exists for complete s plane. This is sigma and this is j omega. So it is exists for complete s plane. For whatever the value of s, we have Laplace transform for del of t, that is equal to 1, because the Laplace transform does not depends on s. That means entire whatever the value of s, it is convergent. Okay, that is the thing. Whatever the value of s, e power 0 is equal to 1. So it is a convergent. If it is goes infinity, then it is not convergent. If it is a finite value, whatever the value of s, it is a finite value. It will give you finite value because the term is not depends on s. Okay, so naturally it is a finite value. So naturally it is convergent for all the values of s. Next, another standard signal is u of t. So instead of x of t in the definition of Laplace transform, you are going to substitute u of t, and you know very well u of t is the unit step function. So it is exists for t is greater than or equal to 0. This is u of t, greater than or equal to 0, 0 otherwise. When the t is less than 0 means it is 0. Okay. So next we change the limit. Here instead of u of t you are going to put 1 for the limit 0 to infinity, because if the value is less than 0 means it is equal to 0. So again you are just going to do simple integration, e power minus st divided by minus s, and you are going to substitute the limits. That is upper limit infinity, lower limit is 0. Here e power 0, here you don't have any problem because it is not depends on s. E power 0 or anything multiplication with this 0 means it is 0. This term will become 1. Only the problem is this term, because here it is infinity. Based on the value of s, whether you are going to get positive infinity, e power minus infinity or e power plus infinity, that is this decided by the term of s. If the s term is greater than 0, that is if term is positive, then naturally this term will become negative. This is negative. That is because this infinity, and this is S is sigma plus j omega. Here when you are going to find out the region of convergence, you need not to bother about the j omega, you just to bother about only the real term. Okay, so naturally if the real term is positive, that is sigma is positive, means this is become e power minus infinity itself. If it is negative, that is sigma is less than 0, means then negative, already you have negative symbol, then this is also sigma also is negative, negative plus, then naturally e power infinity, that will not be a convergent. So for this transform, Laplace transform u of t, the sigma value should be greater than 0, that is positive. So if you see the diagram, this is sigma and this is sigma is equal to 0. So this is the region of convergence of u of t. Okay, this is the value of sigma should be greater than 0. So naturally in the definition, this term is becomes 0 when sigma is greater than 0. Then this minus and this minus, and it is 1. So minus 1 divided by minus s, that will give you what? That will give you x of s is 1 divided by s. So this is the Laplace transform pair. Laplace transform u of t is 1 divided by s. Region of convergence, entire right half of s plane. Otherwise you can say sigma is greater than 0. Okay. Next standard signal is ramp signal. So ramp signal can be written as t into u of t. Okay. So instead of ramp signal, we are going to substitute that t into u of t. Okay. So here we know very well that u of t is 1 for t is greater than or equal to 0. 0 otherwise, or you can say for t is less than 0. So naturally the limit is the u of t is 1 and the limit becomes 0 to infinity. Okay, so again you have two functions, that is you can use integrate because both functions depends on t, both are dependent of t. So we have to use that integrating by parts formula, that is integral of uv dt. Okay, that is equal to u v1 minus integral of u dash v1 dt. Here u dash is equal to du divided by dt. v1 is equal to integral of v dt. So here this is your u and this is your v. So here substitute u t, then integration of this will be e power, here v1. Okay, so integration of this will be e power minus st minus s. Then you are going to substitute the limit for this, again minus u dash is in differentiation of t, that will become 1 because you are going to differentiate with respect to t only. Then v1, this is v1, this is your v1, this is v and this is v1, because if you are integrating this you will get this. First we will concentrate on this term because we have to find the region of convergence. For this we use just to substitute the limit, upper limit and lower limit. If you substitute the upper limit, it is infinity, then e power minus s infinity, again s is sigma plus j omega. This term will convergent when s is greater than 0, or you can say sigma is greater than 0, as we seen in the previous problem. Okay, so totally this term will become 0 when sigma is greater than 0. See here, this is become 0 when sigma is greater than 0. Next you will concentrate on the next term. Here you are going to integrate, so you just take this 1 divided by 1 minus s outside, so naturally this is becomes positive. Okay, then you are going to again integrate e power minus st, So it will give you e power minus st divided by minus s. Okay, again you are going to substitute infinity upper limit and lower limit, just like the previous problem. If this term is greater than 0, it is convergent. E power 0, that will be 1. So this term will be 1 0 when sigma is greater than 0. Naturally it is 1 divided by s into 1 divided by s. So it is 1 divided by s squared. So region of convergence is sigma is greater than 0. And you can write t u of t is equal to 1 divided by s square. This is general form. T power n, this is u of t will come. T power n u of t, that will be n factorial of divided by s power n plus 1. For example, t squared u of t. What will be the Laplace transform? It will be 2 factorial divided by s power 3, because 2 plus 1, that is 3. Similarly for t cube u of t, the Laplace transform will be 3 factorial divided by s power 4. The region of convergence again 0 is greater than, sigma is greater than 0. So this is the general form you need to remember. Tn, t power n u of t, that will give you n factorial divided by s power n plus 1. And another important standard signal is x of t is equal to e power minus at u of t. And again in your Laplace transform general definition, you are going to substitute this. Instead of x of t, you need to substitute this. And again u of t, we know that u of t is 1 for t is greater than or equal to 0, 0 otherwise. So naturally the limit is changing, that is changed to 0 to infinity, and instead of u of t you are going to substitute 1, and you are just going to combine the exponents. So e power minus common, then s plus a of t, and you are just going to integrate this with respect to t, and you are going to substitute the limits, upper limit and lower limit. Now you have to concentrate on this upper limit, because if you substitute the 0, naturally this term will become e power 0. So that is not an issue, it will become 1. So convergent problem will not come here. That will become s plus divided by 1 divided by s plus a. Here there is no problem of convergent. Only problem is with when you are substituting infinity. T is equal to infinity, the problem comes. When you are substituting t is infinity, whether it will become e power minus infinity or e power plus infinity, that will be decided by this term. So this term has to be greater than 0. Then only this minus, if you substitute infinity, that will become remain as a minus infinity. That will be convergent. So naturally sigma should be greater than minus a. Otherwise you can say sigma, you can just leave it, sigma plus a should be greater than 0, then sigma is greater than minus infinity for the condition of convergent. Naturally this term is 0 when sigma is greater than minus a. Okay, then e power 0, that is 1. So 1 divided by minus s plus a. Here already you have minus, so that will give you 1 divided by s plus a. The region of convergence is sigma, that is greater than minus infinity. So in the s plane, you just draw the diagram. This is your minus, this is your minus a, this is sigma is minus a. So this is the region of convergence of this e power minus at u of t. Okay. Similarly, there is another signal, that is minus e power minus at u of minus t. So this is the time reversed signal of step function. This is 0 to minus infinity. This signal exists for 0 to minus infinity. By the definition, you can say u of minus t is 1 for t is less than or equal to 0. less than or equal to 0, 0 otherwise. If t is greater than 0 means u of minus t is 0. Again, you are going to substitute the limits here. So u of minus t is 1 for this limit. Okay, so naturally you are going to take the minus sign outside and e power minus s plus a t. Okay, then if you integrate, you will get this, and you are going to substitute the upper limit. This term you don't have any problem. E power 0. Okay, e power 0, that is going to be 1. Okay, here you are going to have minus. Okay, here you are going to have minus, then the infinity also minus infinity. Okay, so it is a minus infinity means, you see that function e power minus s plus a t. If you substitute here minus infinity, you could see this here separately. If you substitute here minus infinity, the term will become s plus a plus infinity, because already you have minus here and this is also minus. So this is, so for the convergent it should be e power minus infinity. When it will be e power minus infinity? When this term is plus. When this is positive term, naturally this will become minus. Sorry. If this is negative, if this term is negative term, because already it is positive, if this term is negative, that is s plus a should be less than 0, that should be negative, then only this will be e power minus infinity, then only it will be a convergence. So naturally this s plus a should be less than 0, then s should be less than a and less than minus a, then sigma should be less than minus a. So naturally this term is convergence. This term is convergent when sigma is less than minus a. For this term there is no problem. For t tends to infinity, this term e power 0, that is not an issue, because that is not depends on s term. So naturally this is 1 divided by s plus a. Okay, so see the graphical representation. This is sigma is minus a, so sigma value should be less than minus a for the convergence. This signal will be convergent when sigma is less than minus a, otherwise it is not convergent. Okay, the Laplace transform of this signal is convergent to 1 plus s plus a when sigma is less than minus a. This is really an important condition. Similarly, we can derive for e power plus at u of t. We already know that e power minus at u of t Laplace transform is 1 divided by s plus a. Region of convergence is sigma is greater than minus a. But wherever you had minus, you just to put plus. Wherever you had plus, you just to put minus. That's the thing. Because here you have minus, so put the minus here. And naturally this is now, this is minus, so here it is plus. So now this is plus, so it is minus, and here it is plus. Okay, similarly for this function, minus e power at u of minus at. So we already know that minus e power at u of minus t is Laplace transform is 1 divided by s plus a. Only difference is for this function and this function is the region of convergence. Sigma should be less than minus a. Here it is minus, it should be minus. So here it is minus, so it is plus here. So here it is plus, so it should be minus. Again this is plus here, because here it is minus a. Just to change the sign of a in both places. That's the easy conversion. One of the important thing I forgot to tell you, what is the significance of ROC? See, for this function and this function, the Laplace transform is same. So when you are going to take the inverse Laplace transform, it is hard to tell whether the original signal is this or this, because both Laplace transform is same. So when you are going to take inverse Laplace transform, we should have some clue whether the original signal is this signal or that signal. So the real important parameter here is ROC. Only the ROC tells us whether the original signal is this or this. So this is really the most significance of your ROC. It helps you to find out when you are going to do the reverse process. That is, after taking the Laplace transform, naturally we have to go for inverse Laplace transform to find out the signal in, because we are going to take the time domain to frequency domain analysis only for the analysis purpose. Again we need the signal in time domain, that is the original domain. So when you are going to take the reverse process, inverse Laplace transform, when you are going to take inverse Laplace transform, we need to know, because both this and for that function both having the same Laplace transform, only the region of convergence is different. So with the help of region of convergence only we can define whether this signal is inverse Laplace transform, this signal is this or that. So this is really the significance of ROC. Okay, hope you understood the whole presentation. Okay, thank you very much.